And what's really interesting about this whole interaction between these three proteins is I often will tell my students, myosin is in love with actin. Myosin wants nothing more than to bind to actin and cuddle, or what we'll refer to as ratcheting a little bit later on. But TTC, you could kind of think of them as the protective parents of actin. They don't want myosin cuddling and ratcheting with actin, they're trying to protect it. So when you see TTC covering up the binding sites of actin, that's when a sarcomere is in a resting state. But for us to understand how a muscle fiber contracts, we need to go back to the neuromuscular junction, where we learned that that lower motor neuron released acetylcholine, and the acetylcholine would bind to the acetylcholine receptors in the membrane of the muscle fiber. And when this occurred, it caused ion channels within the membrane of the muscle fiber to open up, and sodium would rush into the muscle fiber, creating an action potential. Now, if you don't feel like we've gone into the weeds enough, we could go further into the weeds when we talk about the action potential that occurs with muscle fibers, but we're going to save that for another video. Today, what we need to know is that when this action potential occurs, it affects a specific structure within the muscle fiber called the sarcoplasmic reticulum. And this sarcoplasmic reticulum is in close proximity and wraps around these sarcomeres, and it contains calcium. So when the action potential occurs, it causes the sarcoplasmic reticulum to release the calcium, and then calcium binds to TTC. And when calcium binds to TTC, it causes the TTC to change its shape just enough to slightly move out of the way and expose those binding sites on actin. And what will myosin do as soon as those binding sites are exposed on actin? Myosin's going to bind and ratchet, or what we kind of referred to as cuddling earlier. But you can see that ratcheting, or some books will refer to it as the power stroke, that's going to pull and start to shorten the sarcomere. And what's interesting about this bond between myosin and actin is that it requires a high energy molecule, ATP, to actually break that bond. So we burn an ATP, the myosin will release and actually reset the head, but then bind to a further down actin molecule and ratchet again. Use another ATP, reset, bind further down, and ratchet again. And you can see that would shorten by ratcheting and ratcheting and ratcheting the overall sarcomere, and therefore shorten the overall muscle fiber. And what's crazy to think about is there are multiple myosin heads, multiple actin molecules doing this within each individual sarcomere, and it's just happening ridiculously fast. Like every time I'm moving a muscle, these sarcomeres are shortening and I just can't keep up with it.